All right, welcome. I am Ryan Holger with Temperature Equipment Corporation. I am going to be your tour guide for the next hour and 15 minutes as we navigate the International Energy Conservation Code. We are going to stick on to HVAC topics. As you probably know, generally the state, every time we change to a new energy code in the state of Illinois, which we do every 3 years, by the way, the state does a full training launch program throughout the year, educating inspectors and engineers and contractors and everything like that. However, with the state budget being frozen for non-essential things, that training isn't happening yet. So I figured we'd do this webinar to at least get some basics covered. It won't be the full 8-hour class the state does, but we'll get what we can do in an hour and 15 minutes. I also will point out that I don't work for the state of Illinois. I don't work for a particular village. So officially speaking, anything we talk about today, those are my opinions, not anybody's particular, state stance on the code, right? Just got to kind of say that for legal reasons. All right, so let's get into stuff. First thing I want to point out before we talk about the actual code is that there is a lot of confusion between Department of Energy product rules and building codes. As you may or may not know, the Department of Energy specifies minimum efficiency levels for many types of equipment, which do include lots of HVAC equipment. The ones on the screen here is just a partial list of equipment. The list is way longer than this. Department of Energy sets those minimum efficiencies, and that's really, for the most part, enforced at the manufacturing level. After a certain date, the manufacturer can't make certain things or ship them into certain regions of the country. Building codes are totally separate from that. Building codes are policed at the local level, which sometimes is the state, sometimes the county, but usually it's the municipality. And those building codes often are not directly connected to the DOE rules. So it may be possible for a manufacturer to make something still nationally, but you're not allowed to install it in Illinois, for example. So I just want to point those out, two different unrelated sets of rules. Today we're going to focus specifically on building code discussion. So as you probably know, the IECC stands for International Energy Conservation Code. It is written by the IECC, which is a merger from about 10 years ago of 3 of the regional code groups, Boca being the one we had here mainly in Illinois. So they got together and said, hey, let's just write everything for everybody and make it all consistent and make everyone's life easier. There are chapters in the code book for both residential and commercial. We will talk about both of those today. The residential only has a few changes. The commercial has tons of impactful changes. The IECC also does reference ASHRAE 90.1, and the 2015 version of IECC points to the 2013 version of 90.1. They are generally offset by about 18 months. Both are published every 3 years and updated every 3 years. So 90.1 2013 and IECC 2015 are very, very similar, like 90% the exact same wording for the most part. Additionally, the IECC allows you to use 90.1 as a compliance path, and we'll talk about that a little bit too. In Illinois specifically, there is some confusion that the state energy code only applies to new construction. That is not true in any way whatsoever. It applies to everything, new construction, retrofits, renovations, additions, everything. And we'll talk more about that here in a couple minutes. We've had a statewide code since 2009 version of IECC, and residentially we've had it since, state code commercially since 2006, residentially since 2009. As of January 1st, 2016, we did switch over to the 2015 code book. So we went from the 2012 to 2015. That doesn't mean every municipality is aware of that yet. That doesn't mean they're all officially policing it. However, it's what you should be designing your systems for. Even if your town doesn't police the code, or if your town doesn't even have an inspector for that matter, that doesn't mean you don't have to follow the state code. You always have to follow the state code. If you want to take your chances, legally speaking, and risk it that no one catches you, that's your thing. But technically, you have to follow it even if no one catches you. Illinois does have some amendments, mostly on the residential side, and we will talk about those today as well. Individual towns or counties could adopt a code more stringent if they wanted to, but they can't adopt their own energy code that is less stringent. On the residential side, they don't typically have that flexibility, with very few exception of a few cities that have gotten an exception, generally based on population size. So for the most part, let's just assume for today, everybody is using the code that we're talking about, although you could have a specific niche community that has a code that's even harder than we're talking about today. But no one's going to have one that's easier. And then in Illinois, we do update it automatically, and that's in quotes, every 3 years now. It used to be a separate law that had to be passed every 3 years. Then in 2012 version, the law was changed to automatically adopt without having to go through the representatives and senators. So it went live as of 3 weeks ago with the new code. So hopefully you've all been following it for the past 3 weeks here. We'll start on the residential side and then we'll dive into the commercial side. Residentially, this is what things have kind of looked like over the years. Codes did not get much more efficient each year. They kind of just updated language and stuff like that. Then starting around 2004, 2005-ish, we started having these goals to get these much bigger improvements in energy efficiency through the code spectrum. And really kind of the magical goal is by the year 2030, we are net zero energy. I don't know that that'll ever happen, but that's sort of kind of the magic goal. So every 3 years, expect there to be another 10, 15, 20% energy improvement in the language of the codes that you got to comply with. Here in the Midwest, this is where states currently stand. We mainly are focused on Illinois today, so I'll try to stay on track with that. Illinois is in blue, and this particular screenshot was taken in 2015, so that's why it was in blue. If we took the screenshot today, Illinois would be painted orange, meaning that it's on the newest, most current code. And our neighboring states are kind of all over the map. White basically means you're the Wild West and you don't have codes. Everybody else, green is a relatively current code, yellow is a little bit older, and so on. If it's a diamond shape on there, that means it's evolving to the next version of the code. If you want links to these charts online and stuff, you can just send me an email or whatever, and I'd be happy to send you this kind of stuff. Nationally, same kind of thing. We won't go through it in great detail. I'll just point out that residentially, that Vermont and Maryland already did last year, switched to the 2015 IECC, and Illinois is basically the third state residentially to switch over. So that's good and bad. It's good because we're forefront leaders on energy savings, but it's hard because some of the way things get interpreted, we can't look to neighboring states to see how they were interpreting it because the neighboring states aren't there yet. So they're going to have to look to us eventually. Commercially, same kind of story. Codes are getting more and more stringent every 3 years till we get to the magic goal of not using any energy. My fingers are crossed. I know you can't see them, but they're crossed. Regionally, once again, Illinois is switching to 2015. Our neighboring states are all pretty much in line with us. The blue ones are on 2012, green is 2009, and once again, white is the Wild Wild West. So you see that Michigan is going to be switching over very shortly here as well, as is the city of St. Louis. I think that's St. Louis there. And then nationally, same kind of thing. Vermont and Maryland plus New Jersey already switched over. So Illinois is the fourth state to switch over on the commercial side to the most current code. So same kind of interpretation struggles are likely to happen there. So we get a lot of questions on when did the current, although I should now say the old code apply, and when does the new one apply, and is there any differences? A lot of folks incorrectly assumed it was only new construction. That has never been the case for any of the IECC codes. They apply to everything. So new construction, additions, alterations, renovations, and even repairs have always had to comply with the code. Now, your inspector may not have interpreted it that way. Maybe he was just giving you a favor, whatever. But generally speaking, that's how it should have been interpreted. Everything would have had to comply. So as soon as you took something out of the building and put a new replacement thing in, the new replacement thing had to comply. The rest of the building didn't, but that new widget you would put in would have to comply. It is a little bit different now with the 2015, and we will talk about that in detail today. So now you'll see generic literature on the 2015 say, oh no, for additions and alterations and repairs, you don't have to comply with the code anymore. And to some degree that's true, but only for certain parts of the building. And generally those certain parts have nothing to do with HVAC. And if you go read all the language, and I blew some of it up here because I'm not going to read you everything in the whole code book because that's lame. But the things I will point out are things that I think are critical. And just to point out to you, like in regards to additions, it still says you have to comply with section C403, which is the bulk of the mechanical section, right? So even though some things like maybe roofing doesn't have to do it, I don't know if it does or doesn't, I'm just making up roofing, but the HVAC stuff pretty much does. Alterations, same kind of thing, says yeah, for alterations, for heating, cooling, and ducting systems, yeah, you got to comply with the code, right? And then same thing, kind of thing for repairs, right? Yeah, you still got to comply with the code. So you still got to do it for everything, but it's worded different than it used to be worded. So just the easiest thing to do is just think in your head, if I take it out of the building and I put a new thing in its place, new thing must comply, right? In terms of compliance, there are generally 3 major ways to comply with the energy code from a commercial perspective. Residential, it's a little bit different, but for commercial, there's 3 ways we can comply. We'll start with number 2 on the list here, and it's number 2 because this is the way the code, I snapshot the code for this, but number 2 basically means go into the code book, read all the sections, do what all the sections say, look at the tables for equipment efficiency, do what the tables say, right? Prescriptive, just do what it says, right? Option 3 would be do the things in the code that are listed as specifically mandatory, but the things that are sort of prescriptive, those ones you don't have to do. Instead, what you could do is you could do an energy model of the building, assuming you built it all that way, and then do an energy model of your building the way you want to build it. And if you can beat the base building, the reference building by 15%, then we'll say you're compliant, right? So maybe I don't want to do a certain thing in the code because it's not conducive to my project needs. So I got to make that thing up in some other area of the building and make that other thing more efficient to make up for the thing I'm going to do that's less efficient. So you got like a trade-off scenario. And then option 1 is that instead of doing the IECC, you could take that entire book if you want, commercially speaking, throw it in the trash, and follow 90.1 2013 instead, right? The only thing to keep in mind with that, like I said, they're basically 90% the same, but there's always a few things that are different. But the thing to keep in mind in that is it's not an HVAC choice to do that. The whole entire building has to either follow the IECC or the whole entire building has to follow 90.1. So the HVAC engineer can't say, oh, we're going to do 90.1, and the lighting guys say, oh, we're doing IECC. Everybody's got to be in agreement, and you got to stick down the same path together for the building as a project team. So most of the time, option 2 is what happens for most small, normal type buildings. And as you get into more complex buildings and high performance buildings, you'll see option 1 and 3 come into play a lot more. All right, so let's do our first poll question. And as I said, if you need PDHs, you have to do the poll questions. If you don't need PDHs, you're still welcome to do it because poll questions are fun. All right, so here's the first question. What is the current Illinois Energy Code? Right? Choice number 1 is 90.1 2010, 90.1 2016, IECC 2015, 2016, or 2012. So which one is our statewide code right now as of this month? By the way, if you guys have questions you want to ask me, you're welcome to type them in. Usually I'm pretty good about checking the questions and answering them on the fly. I will try to do that today, but with hundreds and hundreds and hundreds of people on here this time, I might not be able to do them all. So if I don't answer your question, you're welcome to email it to me later, and I'll get back to you on it in the next couple days. But I'll try to answer them on the fly if I can. 89% of the people have voted, so I'm going to close the poll in 7 seconds. 6, 5, 4, 3, 2, 1. All right, and I will share the results with you. 84% of you got the correct answer, which is that IECC 2015 is our current state code right now today. So let me close the poll back down and go back to our regular screen. All right, so back to our regular screen. So let's talk about the HVAC language as related to residential. We'll probably spend 10, 15 minutes on that, and then I'm going to switch over to commercial, which is where a lot of the big changes are at. So I'm not going to read every section of the code to you because that, like I said, is lame. I'm going to point out things that are either new, or I'm going to point out things that have been misinterpreted that I believe the state's going to have the municipalities enforce a little more aggressively than they have in the past. So for one thing, I'm shocked at all my thermostat class I do for people that people don't know a programmable stat is mandatory. It's been mandatory for like 4 or 5 years. You have to put a programmable stat in all the time. You have to. A non-programmable stat is not legal to install. I know people buy them all the time and put them in, but it's not legal to install. You got to put a programmable stat in, and initially the set point's got to be 70 and 78 or wider, right? And the customer can do whatever they want once they take hold of the stat, but that's what you got to start it as for the daytime set points. So I'll point that out. I will also point out that hydronic boiler systems, hot water systems, so steam's not part of the discussion, but any hot water system has to have outside air reset on it. It's not a choice. You have to put it on there. Condensing boilers usually come with a free outside air reset control automatically built in. You just got to mount the sensor, right? Non-condensing, entry-level boilers typically don't have that. You've got to buy a third-party one, from whatever, Tecma or Honeywell or whoever. You got to buy a third-party one. You got to put it on there. Snow melt systems have to be controlled. You can no longer put a snow melt system on a switch. People put the switch on, they forget about it for 3 weeks, they get the utility bill, and they say, what the heck? You can't do that. It's got to be on a control system. You got to have either a pavement sensor with a precipitation sensor, or you got to have a hard shutoff based on outside air temperature. But you have to have a control system on the snow melt. The big thing that really changed in all this language here, because most of it's the same language as the current code, the big thing is that the old language for programmable stats just said programmable stats are required for forced air furnaces. Now it says at least one thermostat should be provided for each separate heating and cooling system. It's no longer isolated to thermostats. So boilers have to have a programmable stat. Even radiant heating has to have it. And I know it's stupid on radiant heating because of the lag time, but technically that's what you got to put on there. My guess is people will unprogram it, but technically that's what you got to do to comply. So that's the big change there, everything. Duct sealing and insulation. When I first went through this, it looked like there was a bunch of changes. Then I realized most of the changes are just verbiage changes just to clean the language up, and most of it's really the same. But there are a few things that are different. So for insulation, if the supply and return ducts are in the attic, they must have R8 insulation, unless it's a really, really small pipe, less than 3 inches, which you would not do very frequently other than a high velocity. So a high velocity would only have to have R6. But your normal attic ductwork, supply and return, has to have R8 insulation on it. Any ductwork that goes through other unconditioned portions of the building would have to be R6. So unconditioned basement or crawl space needs R6. Attics need R8. And then if all the ductwork is inside the thermal envelope of the building, you don't have to insulate it at all. The big change in that regard is the attic return. Previously, attic returns only had to be R6. Now the attic returns are bumped up to match the supply, so they both have to be R8. In regards to duct sealing, nothing really changed major there. You still have to seal all the ducts in the entire house, and the air handlers and the filter boxes. Everything's got to be sealed. So that does not really change at all. You can use, UL tape, you can use mastic, you can use aerosol-based stuff, but you have to seal all the ductworks. Additionally, any ductwork that goes outside the conditioned envelope. So as soon as one piece of the duct system goes outside the conditioned envelope means attic, crawl space, something like that. As soon as you do that, then you not only have to seal the ducts, you also have to pressure test them, and you have to get them down to a certain leakage in order to comply. This language all changed since the 2012 version. However, when you look at it, it ends up basically meaning the same thing, which is that if my furnace is installed already when I do my duct leakage test, then I'm allowed at a maximum 4 CFM for every 100 square foot of house. So to keep math easy, if I had a 1,000 square foot house, I would be allowed 40 CFM maximum duct leakage tested at 25 pascals, which is a 1/10 of an inch. If my furnace was not installed yet, then I'm only allowed 3. So in my example of a 1,000 square foot home, 30 CFM of maximum leakage done at a typical duct test of 25 pascals. All right, so that's kind of the deal with that. Nothing really changed in terms of what you have to do. The language is all reworded, but I'm interpreting it to basically mean you have to do all the same stuff we had to do previously. There is still a section in the code that requires you to do an ACCA manual J calculation for a heating and cooling system install. You also have to do manual S, which is equipment sizing. So you got to do the manual J, which calculates the loads. Then you have to apply manual S using those loads to correctly select the equipment. And for the most part, what manual S means, if you're not familiar with it, it kind of really prohibits you from oversizing and upsizing things too much. So you kind of have to go with the load calc, if you will. What's new in the language of this section that wasn't there before is that last sentence: new or replacement heating and cooling equipment shall have an efficiency rating equal to or greater than the minimum required law, blah, 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 for each geographic region. So basically what they're doing here is saying, hey, remember those DOE rules Ryan set up at the beginning of the presentation? Yeah, for residential, you got to follow those DOE rules. So whatever the current manufacturing DOE rules, right, which is, 13 SEER, 80% furnace, whatever it is, you got to do those. If you happen to have an old 78% brand new furnace in your warehouse, you can't sell it to someone and install it at their house. You got to comply with the current federal law, which is the DOE rules. So that's the big addition in that particular section of the code. I often get a lot of questions about outdoor air temperature to use for Active Manual J. It's not specified specifically in the code, and most building inspectors are okay with different sources of data as long as they're credible sources that you can cite. So I can use ASHRAE fundamentals handbook data, I can use NOAA weather data, but I can't use Uncle Tom's thermometer, right? I have to have some cognizant source that I can point to and show him where I got the data from. And then if you do that, most of the permit reviewers and inspectors have been like, okay, yeah, you want to use ASHRAE data, fine, right? So specifically for Chicago O'Hare Airport, which is where most of you guys are closest to, the ASHRAE weather data would be minus 1.5 degrees in the winter and 91.4 degrees in the summertime. Those are your design temps. So if you put in the old school 1960s numbers of minus 10 and 95, a lot of the permit reviewers are going to flag that and say, dude, redo your load calc. This isn't going to work. You got to put the right numbers in. Otherwise, you're going to be upsized too much. And a whole slew of problems come with oversizing, which we don't have time to talk about today. So there's some Illinois and Indiana typical cities out of the ASHRAE handbook. I don't have the NOAA weather data handy, but for the most part, the numbers are within like a degree of each other, typically pretty close. Minnesota, Wisconsin, I know a bunch of you guys logged in from those states, right? So if you're in Duluth, minus 18 is your design number. I know a lot of you guys like to use minus 30 up there. It's not your number. Your number's minus 18. But you don't have the Illinois code yet, so you don't have to worry about it. There's a bunch of other stuff in the residential code that we're not going to have time to look at today. I wanted to focus on the HVAC stuff, and that was pretty much all of it. But there's a whole entire expanded section on what I'm going to call domestic water related things. So recirc systems, service hot water, that kind of stuff. So there's all kinds of rules and stuff on that. There's also rules for insulating the pipes and those sorts of things. So we can't cover everything today, but I wanted to highlight some of the bigger stuff so you can kind of see that. All right, quiz question number 2 before we switch over to commercial. True or false? Residential duct sealing is mandatory statewide in Illinois. It's true or false? Simple yes or no question. Here we go. While doing that, I'm going to go read a couple of the questions you guys typed in. All right, Bernadette asks, can you clarify programmable thermostat requirements for residential radiant heating? Is the requirement for zone radiant heating systems in a home? So the programmable thermostat requirement is for all heating and cooling systems. So all would include radiant systems. What I was saying on radiant specifically is that I personally don't believe in programmable stats on radiant because it takes like 12 hours to heat up the floor and so forth. So the lag time is ridiculous. So it doesn't really make sense to me, but the code technically does require programmable stats on every single thing that produces heating or produces cooling effect. So hopefully that answers Bernadette's question. Melanie asks, IECC 2015 indicates that the building energy cost must be 15% less than of the reference design, but 90.1 indicates that the design must only be less than the budget building. So it appears that 90.1 would be less stringent. Is that correct? I would say on the surface that would be correct, Melanie, but like I said, the requirements of the two codes are not absolutely identical. There's whole sections of 90.1 that never made their way into IECC, and there's things that are added to IECC that are not 90.1. So as a general statement, I would say, yeah, you're probably right. If you want to do the energy modeling scenario, 90.1 might be an easier pathway for you to take, but if, depending on certain things you might have in your building, that may not always be a true case. Sean asks, inside or outside the thermal envelope does not matter anymore for attic. It does matter. Let me go back to that, Sean, and I'll try to make that a little more clear. I'm assuming you're referring to insulation. So here you see where it says exception, duct or portions therefore located completely inside the thermal building thermal envelope do not have to have insulated ducts, right? There's a definition, it's in italics, so there's a definition in the code for building thermal envelope. But really what it comes down to is where is my insulation barrier and where is my air barrier? So If I want, instead of putting my insulation air barrier on the floor of the attic, if I put those things on the ceiling of the attic, now all my ductwork is inside the building thermal envelope, and I don't have to insulate it if I want to, because I put it inside the insulated building already, right? So if that's what you're referring to, I think that's probably what you meant there. All right. We'll have to hold off on the other ones for now so we can get back to our poll question. I'm going to close that. 91% of you said that is true, and that is correct. All right, so like that, we'll jump back over to our code section and get back to where we were. We're just about to get into commercial, or well, actually, sorry, we have one more residential thing to talk about. This one is really a weird one because it directly ties to an Illinois amendment. So one last residential thing. So in the IECC, there is a section for mechanical ventilation requirements. This got added 3 years ago, and it has not changed, but it is something the state has stressed they are going to be enforcing more strictly this year. And as you know, the state doesn't enforce it, the local municipalities do, so the state will be advising the municipalities how to enforce it more strictly, if that makes sense. So because the building envelopes got really tight 3 years ago, they said, okay, you know what, now we don't have enough leakage to make sure that we have a safe ventilated building, so now we're going to make you have mechanical ventilation brought in. And you got to do it per the IRC, or if it's a larger multifamily building, with the IMC. What that basically means is that you can have an all exhaust system, you can have an all supply system bringing vent air in, or you can have a balance system such as an ERV or something like that. Personally, I'm not a fan of the all exhaust system because if I'm sucking air out of your house in order to draw it in through the cracks to get the ventilation air, that sounds fine on the surface, except that that air coming through the cracks is not heated, cooled, dehumidified, or filtered, and I'm going to bring it into your house. So I'd rather not do that. I'd rather bring it through a controlled opening, like a duct coming into the back return side of my furnace, where I can heat it, cool it, filter it, humidify it, dehumidify it, all that good stuff. So you technically could do exhaust only. I would not recommend that, especially in our climate, especially in the summer months. Supply only would be better, and then obviously balanced would be the best scenario. The weird gotcha on this is that a whole house mechanical ventilation system has to have a certain fan efficiency, and I didn't put the table on here. I'm not sure why I didn't do that, but I can get it if anybody wants it. Certain watts per CFM efficiency that I would apply to your fan system that you're using for the whole house system. Then there's an exception on there. You don't have to comply with the efficiency of that table if your ventilation intake fan is part of a tested, listed HVAC piece of equipment. So if you're using your furnace to draw air in through an outside air duct, like almost all of you guys do, then that unit doesn't follow this table efficiency for the fan. Instead, it simply has to have an ECM motor. That has not been policed very hard the past 3 years. It is going to get policed very hard. A lot of builders have already been warned about it. A lot of builders have already talked to you guys, mechanical contractors, about it in the past month. So if you're using the furnace to bring the fresh air into a new construction house or a major renovation project, plan on putting an ECM motor in the furnace. That's the skinny on that. There's a lot of amendments in the Illinois code. A lot of them have to do with residential mechanical ventilation. I'm not going to read all of that to you. I just want to show you the table. In the past, other states that have this section in the code right here, they say, well, how much outside air do you got to bring in? And then they point to ASHRAE 62.2 or some other source like that. Illinois said, no, it's going to be easier. Instead of people doing whatever they want, we're going to give you the table. So the Illinois table is this one on the screen here from the Illinois amendment. It's the same as it was the past 3 years. If we take an example, 2,000 square foot home with 3 bedrooms, we come across, we need 60 CFM of outside air. If I got a bigger house, it's 3,500 square feet with 5 bedrooms, I need 90 CFM of outside air. So it's a simple table, easy to use. The thing to point out on this is these CFM numbers in the table assume you're going to run your intake fan 24/7. If you don't want to do that, you don't have to, and you can cycle your fan on and off. But if you cycle it on and off, you got to beef up the CFM of the outside air intake. Specifically, if you look at the table on the bottom, if I decide I'm going to run your fan 30 minutes out of each hour, I got to double all the CFM values. If I'm going to run it 15 minutes, 25% out of each hour, I got to quadruple all the levels. So if I take your 90 CFM and quadruple it, that's 360 CFM. Your furnace can't handle that. It's going to cause condensation and cause problems. So be very careful about doing a fan cycler or something like that. You're much better off doing the continuous ventilation method. Bath fans and kitchens have to have either continuous ventilation at a very small CFM, or if you put them on a switch, they have to have a much larger CFM. These tables did not change over the past 3 years either. Last thing amendment-wise is that residentially is there's a couple things in there to help clarify on the non-new construction projects. So specifically, additions is one of these sections and alterations is the other section. And basically tells you, hey, if you got an addition or alteration, we still expect you to do the programmable stats. We still expect the boiler reset. We still we still expect the duct insulation and sealing. We still expect the mechanical ventilation, right? We want those things to happen even on an alteration or an addition project or something like that. But it doesn't say you have to do the manual J or the snow melt control or the pipe insulation stuff. It's kind of weird. I don't know why they separated those things out, but that's what they chose to do. So if your inspector comes back and says, hey, you got to put the programmable stat in on your addition, you got to put the programmable stat in, right? But if they don't ask you for a manual J, it's because they didn't have to ask for that. Although I think you'd want to do it, but technically you don't have to. All right, quiz question number 3. Which of the following residential projects would require mechanical ventilation per state code? Choices are a new construction home, a furnace repair, an addition or renovation, A and C, which is new construction and additions, or B and C, which is a furnace repair and additions. So hopefully that one wasn't too tricky. It looks like most of you are answering it correct anyway. While we're doing that, I'll read a couple questions real quick. Where did we leave off? Jay is saying, if you are just changing out a furnace, do you have to seal the existing ductwork? No, you do not have to seal existing ductwork. However, if you modify the ductwork, you add a new run on it or something like that, the new piece of ductwork has to be sealed, right? If I take the furnace out and I put a new plenum in, but I use all the existing ductwork the rest of the house, the new plenum has to be sealed, but I don't have to go seal out the duct runs themselves. In regards to the testing, the duct pressurization testing, most inspectors have said, obviously if it's all new ductwork, you got to do it, but if you have it just a new addition run, most of them have been cool about it and have done a visual inspection because they realize there's no way for you to really realistically test this one piece of duct without all the rest of it. Ryan asks, for residential load calculations, would a load program like HAP suffice? Generally speaking, like on the surface, the answer would be no, but maybe. So the code specifically says you have to have ACA manual J load calculations, right? Or another method approved by your local authority. So if your local inspector / permit reviewer says, yeah, you can use HAP, or yeah, you can use this other method, then you can, but it's at his discretion. ACA is manual J is a guaranteed lock. All right, one more and then we'll cut over. Keith asks, we find most municipalities have adopted 2006 or 2009 IMC, International Mechanical Code, which is not directly in sync with the 2012 and 15 IECC. That's been an ongoing problem with code enforcement and contractors wanting to meet the code. Is the state going to dictate the IMC version to correct this? To my knowledge, Keith, no. I've heard no one mention anything about plans on having a statewide mechanical code. I don't know why we don't. We have statewide electrical, we have statewide plumbing, we have statewide energy, but we don't have statewide mechanical. It would be nice, I agree with you, but the answer is no for right now. All right, closing the poll question. 91% of you got the correct answer, which is A and C. New construction homes obviously have to follow the code, and any additions or renovations also have language where they have to follow the code. If you're just replacing the furnace, or excuse me, if you're just repairing the furnace, bad igniter or something like that, and you had to change it out, then no, you don't have to go do all this code stuff. So hopefully that answers that. So you wouldn't have to add any mechanical ventilation because you changed an igniter on the furnace, right? All right, let's talk about the commercial stuff here. So I'm going to start out with some of the equipment efficiencies because this is probably, for most of you, the biggest, most impactful change that you're going to see, and it is fairly shocking and startling, right? I may be saying that because I work for an equipment supplier, so that's how it is in my world. This is one of many tables in the code for minimum equipment efficiencies, commercially speaking. C403.2.3 parentheses 1 is the first one, and it goes 2, 3, 4, 5, 6, 7. So there's 7 tables like this. This is just a screenshot of the very first one just to kind of get us started. This particular one applies to unitary equipment. So this is basically your rooftop units and your DX split systems and stuff like that. So 55% of the market, if you didn't know it, of the commercial market is rooftop units. So it's a pretty big section of the world, or of the, not the world, of the United States. So the small stuff, under 5 tons, 65,000 BTUs and less, so practically speaking, 5 tons and under, has to be 14 SEER. You can still buy 13 SEER equipment, but you can't install it legally, right? So just keep that in mind. The minimum thing the manufacturer makes is no longer what you're going to be doing in Illinois, right? So the manufacturers usually have like 3 tiers of equipment, good, better, best. In a lot of cases, you can no longer use the quote-unquote good tier. You're going to have to go to the better or best tier. So 13 SEER you can no longer do. You got to do 14 SEER on the little stuff. The bigger equipment, as you probably know, is not rated in SEER. It's rated in EER, which is full load efficiency, and IEER, which is part load efficiency. These have also gone up dramatically as well. I've highlighted 3 common sizes in yellow there. If you notice, for each size range, for example, 65,000 to 135,000, there's 2 buckets. One is if you have electric heat in it, right? The other one is everything else. Everything else means basically gas heat, or I guess theoretically a hydronic coil, right? So that's why I highlighted those, because gas heat units are the most common thing in the Illinois area here. So for those little guys, you got to hit 11 EER and 12.6 IEER. And then as you go up in size, the requirements become less and less difficult to hit because the volume of manufacturing is less, and to get the efficiency, you need bigger units, more weight, and the roofs can't handle it. So they've been a little bit flexible on the big stuff. But these numbers are fairly high, and for the most part, for most manufacturers, none of the entry-level equipment is going to comply. So you got to plan on doing something more stringent. Just for sake of argument, I put in some screenshots of some stuff we were looking at on the Carrier product line, because that's the line we have. This is not a Carrier presentation, but I just wanted to use something as an example. So on the small stuff, 6 to 10 tons, on the 6 ton, we have to go to the medium tier unit, which for us is a 48HC model number. You cannot use a 48TC. On 7.5, 8.5, and 10 tons, we could still use the entry-level equipment if we put a VFD on the fan and do staged air volume control. That does change the IEER rating of the unit and makes it very efficient at part load, because fan energy is a huge consumer of the total energy of the rooftop. So you can either use the mid-tier units, or you can use the entry-level units, but beef them up with a staged air fan, which is basically a VFD running at 2 speeds in there. For the mid-size stuff, it's the same kind of story. The 12.5 ton, you have to go to the mid-tier unit. The 15 and 17.5, you can do a mid-tier, or you can do an entry tier with VFDs, right? Same thing for the bigger ones. So you're going to probably see lots and lots and lots of projects start having staged air volume VFDs in the rooftops, and that may change how your techs have to learn to service these things and so forth. So it's going to be, I think, a pretty impactful change that a lot of people are going to be exposed to that they've never really had to think about before. Only a few guys have been doing staged air fans for the past 3 or 4 years, a few contractors. Not everybody's going to see them pretty much every month. And that's just the rooftop table. There's tables for everything else. I'll show a couple of them later. We don't have time to do every single product category, but you know, P-tax, chillers, everybody's got new tables they got to deal with, and so on. So some of the other stuff in the code, under the control section, there's a couple things to specifically point out. I want to point out thermostats again, because every single rooftop and every single split system's got a thermostat, and the rules for the thermostat are not well followed in the past. I got a feeling this is going to get policed a little harder this year as well. So thermostats, commercially speaking, have to be 7-day programmable. A 5 plus 2 day is not acceptable. It's got to be 7-day programmable. It's got to retain its scheduling even on a power loss. You could do it with a battery, although that's old school. You probably want to do it a double EEPROM chip. That's in a more common way. But you got to retain that. You got to have a way to override the occupancy. So you got to be able to walk up to the stat and push it and get a couple hours of override. Or you got to have a motion sensor or something like that in there. You have to do adaptive intelligent recovery. Every manufacturer stat calls it something else. Basically, this says if I program my stat to go occupied at 8, the stat has to figure out, based on the previous runtime history of the past few days, what time it needs to start today in order to get to the set point that we need at exactly 8 o'clock. So it may start at 7:15, it may start at 6:55, it may start at 7:50 to get us there by 8, but it has to be smart enough to calculate when to start on its own. And the big one, which has been overlooked and now getting policed a little bit more, is that not necessarily the thermostat, but something in the building has to tell the ventilation damper whether the building's occupied or not occupied. And when it's not occupied, you got to shut the outside ventilation damper. What happens on a normal rooftop unit, we have an economizer typically, and the minimum ventilation is set at the economizer. It goes to whatever, 10, 20%, whatever the job required. And it does that, it opens to that position every single time the fan is on. So if I have a heat call in the middle of the night, the fan goes on, the ventilation damper goes open, and I bring vent air in for a building that has no people. The code doesn't allow that anymore. You cannot ventilate a building that's not occupied, right? So you got to shut the damper off. The easiest way to do that is to get a thermostat that costs 20 bucks more than a regular programmable thermostat and has an extra output on it, an extra contact that wires up to the economizer input, and whenever the stat goes to occupied mode, it closes the contact, which tells the economizer, hey, it's occupied. You should go ahead and do minimum ventilation position. And if we don't hit that contact, we don't do ventilation position. That's the easiest way to do it. So think about that when you're selecting your thermostats. Just like residential, we got to have boiler outside or reset. We got to have snow melt controls. There's a whole entire chunk of rules related to VAV controls. I'm not going to have time to go through those today. The same thing with hydronic systems. There's a whole bunch of rules that relate to that. We'll touch on a few today, but we can't go through all of them. So I may have follow-up webinars next month for those more niche categories, for those of you guys that care about it. Today I want to hit the big stuff. So I'm going to kind of neglect VAV and hydronics for today. So I apologize for you guys that love that stuff. Another huge change is with economizers. A whole new section was added to the code for economizer fault detection and diagnostics. That's a big mouthful, so we had to give it an acronym, FDD. All the units that have economizers, and by the way, all units require economizers now, and we'll talk about that in a second, all those systems have to have fault detection controls on them. There's a whole slew of language that goes along with that. You got to have outside supply and return sensors. You got to provide current status of the system and what mode it happens to be in. You have to be able to detect if there's a temperature sensor failure or if the unit's not economizing when it should be, if you've got too much outside air. There's a whole bunch of things it has to do. I've not dived deeply into that and like checked every single economizer controller, but just talking to the Honeywell folks who make like 80% of the economizer controllers you buy on a rooftop, there's only one economizer controller that they have that does that. That's the Honeywell Jade economizer. All the older versions of economizers they've made over the years don't do this stuff. So for the most part, on rooftop units and DX split systems that have economizer controls, you're going to have to put a Honeywell Jade on there or an equivalent from another manufacturer. Belimo's got their thing fine. You can do that stuff. If you got DDC controls, then obviously you don't need the Honeywell Jade, but your DDC system has to mimic what this stuff, the same set of rules you have here. Additionally, I didn't put the screenshot on here, but it used to be that economizers were only required in Illinois for 33,000 BTUs and up, which is like 2.5 tons and up. That requirement's gone. Now everything has to have an economizer. So as soon as you put a mechanical system in a commercial building, it's got to have an economizer on it, right? Every single system. You buy a 2-ton rooftop, assuming you could buy that from somewhere, it's got to have an economizer on it. I see a bunch of you guys typing in questions. I'm going to try to get to them at the next quiz point. Otherwise, I'll never get through all this stuff here. So that's kind of the deal on the economizer changes. Every single system needs an economizer, and additionally, it's got to be a fairly intelligent economizer control. Okay. This is also a pretty big one here, and the way I've worded it is DX staging rules for zoning systems for VVT and VAV. That's not the way the code section is written, but that's the way I'm interpreting it. So for starters, you have to have an integrated economizer control for all systems, right? And that's been in the code for a while. Integrated economizer means that I use the economizer for free cooling when weather's appropriate, and then if the economizer gets all the way to 100% open, I can still engage a stage of mechanical cooling to take me the rest of the way. That way, if it's like 62 degrees out, I don't have to switch over to full mechanical cooling. I can economize a little bit and get the rest of my cooling from the compressor. That's still the case in there. However, the thing that is different is if you look at note 2 over there, anything with economizer also has to apply with these other rules here. And if you look at note 2, DX systems that are 75,000 BTUs and up, and which 75,000 is 6 tons basically, you have to have a minimum of 2 stages. So you cannot have a 1 stage 7.5 ton unit, right? If it's 6.25 tons and up, it's got to have 2 stages. No exception to that, right? The other thing, note 3, which is really what really applies to VVT, VAV, and other airside zoning systems, if you control the space temperature by modulating the airflow to the space, so in other words, you put dampers on it, right, then I have to do that table at the bottom. That table at the bottom says 65,000 BTUs up, which is 5.5 tons and up. I have to have 3 stages of cooling. And 240,000 BTUs and up, which is a 20-ton unit, I got to have 4 stages. So essentially, for the most part, all your VVT systems have to have 3 stages of cooling, and all your VAV systems, for the most part, have to have 4 stages of cooling. It's based on tonnage, not VVT versus VAV. But as soon as you put zone dampers on there, and you're more than a 5-ton unit, you're going to have more stages of heating and cooling capacity. It makes sense. If I'm throttling back your load, because I'm only trying to satisfy 1 or 2 small zones, I need to have that staging capacity in order to avoid short cycling my unit and hence having poor dehumidification and so forth. So it does make sense, but it is kind of weird that they threw this language in under the economizer control section. I don't know why it ended up in there, but as soon as you need an economizer, you got to do this stuff, and every unit needs an economizer, so every unit has to do this stuff. So hopefully that's clear as mud. This next one is also an interesting section, and we've had a lot of debate internally at our office the past month about when this applies and when it doesn't apply. So I'm going to tell you the way I interpret it, then I'm going to tell you the way my coworkers and some of the manufacturers are interpreting it. So this is section C403.4, and to me, based on the title of that section, this applies to all hydronic systems and non-hydronic systems that are multiple zones. To me, multiple zones, once again, means I have more than one thermostat on one system, which means I got VAV zoning, I got VVT zoning, I have some other type of constant volume zoning, right? Some kind of damper control or averaging sensors. As soon as I have more than one point of control on my air handler or my rooftop unit, then this section kicks in my mind. Or if I have a hydronic system, so a single zone hydronic would also kick in. That's the way it's literally worded, so that's the way I'm interpreting it. And if I interpret it that way, then any systems that are greater than 65,000 BTUs, so if you see that table down there, 65,000 BTUs after January 1st, which once again is 5.5 tons. So if I have anything that's 6 tons and up, in those cases I have to have at a minimum 2-stage fan control. So that's just kind of, and once again it makes sense. If you're going to put zoning on there, why let all that bypass air happen and waste all that fan energy? Let's stop doing that. Let's slow the fan down when we can, right, and save that amount of energy. There are specific rules on that. When you read the language of it, it's got to slow down to like 2/3 of the airflow, and use 40% of the fan power. And of course, as you guys know, the fan laws, if I cut it down to 2/3 power, I'm going to be using less than 40%. So that's fairly easy. But I'm going to have to do that on zoning systems for sure. I'm going to have to do it on hydronic fan coils, right, for sure. And then the way my coworkers and some of the manufacturers have been interpreting it, because of note number 1 on here, direct expansion and chill water cooling systems have to have no fewer than 2 stages of fan control. They've been reading that and saying everything has to have it. And I've been reading it and saying, well, the section says hydronic and multiple zone. So that's not everything. So we're not in agreement on that, just so you know. But at a minimum, everybody agrees zoning systems have to do this. So as soon as you have zoning, you need multiple stages of fan. CO2 sensing. This language did not change, but there's been some confusion on it, so I'm going to point it out again. It's the same as the code for the past 3 years. If I have zone spaces that have a average population density of 25 people per 1,000 square feet or denser, then I'm going to have to do demand control ventilation, which means putting CO2 sensors on the air handler, on the zoning, on the rooftop, whatever I got. There are some exceptions to that, and there's quite a few. If I have an ERV, I don't have to do it because ERV and CO2 kind of poach each other's savings because they're both working with the outside air. If I got a VAV system that's old school pneumatic, I don't have to do it because they realize there's no practical way to do it unless you have VDC controls. If I have systems that have outdoor air less than 1200 CFM, which is most small systems, then I don't have to do it. If it's a bigger system like a big VAV job and there's conference rooms and classrooms, plan on doing it. If it's some little 5-ton rooftop somewhere, you're probably not going to have to do it. All right, so just kind of keep that in mind. And then process loads and stuff like that. So that's one that hasn't changed, but it's one to kind of keep in mind. ERVs did have some language changes. What didn't change is how efficient the ERV has to be, or how effective I should say. It's still got to be 50% effective at recovering enthalpy. Enthalpy, as you know, is the dry bulb and the humidity related sources, the sensible and the latent. So if you have a sensible only ERV, it's very unlikely that I'll be able to get 50% of the total enthalpy if I'm only recovering sensible. So you pretty much have to use full enthalpy wheels or enthalpy cores or whatever the case may be. Heat pipes, run around coils that only do sensible probably aren't going to make it, right? I'm not going to read you all this language, but I will show you the table and what specifically changed. So now instead of one table beginning at 30%, now there's two tables and they begin at 10%. The first table is for systems that are less than 8,000 hours of operation. That is most systems, right? So those cases, it used to be 30% and up. I'd have those buckets. So if you can see my mouse, 30, 40, 50, 60, 70, 80%, I had those buckets. And specifically for climate zone 5A, which is where we're at here in Northern Illinois, which is where most of you are from, we had it. If we had 5,500 CFM of supply air and 30% of that came from the outdoors, then I had to put an ERV on there, right? And then 40% bucket was 4,500, 50, 3,500, and the bigger the outside air percentage, the more likely I had to do it. What's new is the 10 and 20% columns. So now if I have a system that's only 10% outside air, but it's a really big system, 26,000 CFM supply air or more, now I got to put an ERV on that also, right? The other thing that is new is the second table. This is for systems that are operating year-round. I realize there's 8,760 hours in the year. The way they worded this was 8,000. That way none of us could say, oh, you know, we take it down 1 hour a year for maintenance, so technically. So that's out of the discussion. So stuff that's operating year-round, then the table's a little bit different. If you look at climate zone 5A, all systems have to have an ERV. So if you're doing a 911 call center, you got to have an ERV. You don't have to do any math, don't look at anything, you got to do it. If you're doing a hospital, ERV, right? If you're doing a police station, ERV, right? Anywhere you know is going to be operating 24/7. If you're doing a 24/7 Walmart, ERV, right? So this is pretty impactful. It affects more buildings than you think. Buildings that operate year-round that don't shut down, or even if they shut down, White Castle. I love White Castle. Don't blame me. I just love it, right? White Castle only closes 1 day a year. Everybody knows that. They close on Christmas, 24 hours of closure. Guess what? 8,760 minus 24 is still above 8,000. Every single White Castle has to have an ERV. Now, with that being said, White Castle is going to not have to do it because the vast majority of their air is probably running through a kitchen exhaust hood, and that falls under the exclusion section. So practically speaking, they won't have to do it. But conceptually, you kind of got what I was saying. There are some other exceptions to point out. If you do not cool the space, exception number 3, if you do not cool the space and you don't heat it above 60, you don't have to do the ERV, right? So that's like your warehouse and stuff like that. You don't have to do it because there's really nothing to recover from. If you have special dehumidification equipment, you might not have to do it. Note number 8 is an interesting one. This is very useful for multifamily buildings. If you don't have one or a couple of large exhaust fans and you have all these little tiny exhaust fans all over the place, okay, we realize that's not practical to recover all those little exhaust fans air, so you don't have to do the ERV in those cases. Number 9 kind of kicks in with like your churches. If you only operate 20 hours a week, okay, we realize there's not going to be enough savings to justify it, so you don't have to do an ERV. Right? The church, they have 2 or 3 services on Sunday, and the rest of the time they're not at peak occupancy, so they don't have to do it. Right? So there's some exceptions like that, but there's going to be a lot of places that you didn't have to do an ERV before, that now you got to do it. So that one's definitely one to kind of keep in mind. All right, quiz question number 4. Which of the following are required on a typical, in quotes, typical 10-ton DX RTU installation? So 12.6 IER, an integrated economizer, fault detection on the economizer, 2 stages of cooling, or all of the above. While you guys are looking at that the next minute, I'm going to go try to hit a couple more of these questions for you. If I can get back with so many questions now, it's going to be hard to get back to where we left off. All right, where do we leave off? Did Keith's. All right, Cliff, I think is where we left off. Will mechanical ventilation now be required any time that air sealing or attic insulation work is performed? That's a great question, Cliff. If you seal the building envelope, there's nothing in the energy code that's going to specifically dictate the mechanical ventilation provisions will kick in. However, you know from a smart standpoint, 'cause I know who Cliff is, as soon as you seal that building envelope up, you're going to want some pathway for ventilation air to get in, or you're going to have other problems, your backdraft appliances and things like that. So I don't think there's going to be a code thing that kicks in that makes you do it, but practically speaking, you're going to want to do it. Leo says that he's seen some studies that exhaust-only mechanical ventilation systems increase radon levels. That could be true in a particularly tight home. If you have radon in the soil underneath you and you don't have a radon system, passive or active, and you start drawing a negative on the house, it's going to suck from everywhere it can, and everywhere would include the ground. So that is feasible. I would avoid exhaust only for many reasons, and that's one of them. How would Christoph asks, how would furnace satisfy ventilation requirements in the mid-season once it's not in operation? All right, so if I'm going to use the furnace as my ventilation intake fan, the furnace has to operate 24/7, or it has to be on a cycle timer. You can't just have it on a regular thermostat in the auto mode. That's not acceptable, and that has not been for quite some time. So you have to run the fan 24/7 or put a cycle time on there and double or triple or quadruple the CFM like we talked about. Pat asked, does a 48 KCE carrier 5-ton rooftop and under hit 14.0 SEER? Yes, Pat, that does. All right, one more and then we'll have to move on here. Ryan asked if we can clarify if the economizer FDD is not required for indoor water-cooled units. So I have not thought about that specific thing, but let's see. FDD applies to air-cooled unitary direct expansion units listed in that table and VRF systems with an economizer. So no, you don't have to do FDD if you have let's say a water source heat pump. Is what you're asking, Ryan. No, because a water source heat pump is not a direct expansion unit. All right, so let me get back to the quiz question. All right. 97% of you are correct and said all of the above, right? All those things have to be done on a typical 10-ton unit. It's got to meet a certain efficiency. It's got to have an integrated economizer. I got to have FDD, fault detection on there. I got to have a minimum of 2 stages of cooling. All right, let me get back to our slide deck. Sorry about that. All right, question number 5. We'll go ahead and do that right now too. If a zoning system is applied to that previously mentioned typical 10-ton RTU example, so now it's no longer typical, we added a zoning system, which of the following is also required as a minimum? 3 stages of cooling operation, staged air volume or VAV air volume, demand control ventilation, A and B, which is 3 stages plus SAV, or A and C, which is 3 stages in DCV. I know that one's a little bit harder, but hopefully you guys are all paying attention on that. While you're doing that, I'll look at a couple more questions. For economizer fault detection, how is it expected to measure excess outdoor air? Is this an airflow station? That's a great question, Wade, and we've had that debate this morning with some guys in our office. I don't know that it has to be an airflow station specifically. You could have a controller that's reasonably intelligent enough to detect that temperatures of outside compared to mixed air are not in sync with what you would anticipate, and you might be able to calculate it that way, but it does not specifically mandate an airflow station. That obviously would be a logical, easy way to do it, intuitive way to do it, but you could do it with temperatures, I would suspect. Tim asks, economizer on VRF, is code specific on how that is done? No. The code doesn't tell you how to apply an economizer to a VRF system, but there is a requirement for the economizer on the VRF system. So that's an interesting debate, and it's kind of a gray area, and I don't have a good answer on that one. One more from Marcos. Does the OA intake duct need to be full size of the system? I'm assuming you're talking about commercial, because the timeline of your question was 1 p.m. So I'm assuming you're talking about commercial. The economizer has to be able to do 100%, right? The ventilation only has to do what the code required ventilation requirement is, and that's going to come from the mechanical code or from ASHRAE 62.1. If you're talking about residential, then the outdoor intake duct needs to be sized to handle the CFM that's required in the code table we went through earlier. So our example of the 60 or the 90 CFM type thing. All right, our poll question. Correct answer was D. A lot of you guys struggled on this one, I think. 3 stages of cooling is required once I have the zoning system on that size unit, and I have to do multiple speed fans, so staged air volume or VAV. So the correct answer is A and B, so D is the correct answer. A lot of you guys picked E, which was A and C. DCV is not required on a typical 10-ton unit with zoning. It could be required if I had some big, huge zones that were densely occupied, but on the typical answer, A and B only. All right, let's get back to our slides. We got about 6 or 7 more, so we should be pretty good on timing here, and then we'll hit the rest of these questions. I know we said we're going to talk about all the hydronic control rules, but we do have to talk about a couple hydronic things because they're pretty impactful, broad stroke changes. One is boiler turn down. So this is a new section. Boiler systems that are larger than 1 million BTUs have to have a turn down ratio of 3-to-1, 4-to-1, or 5-to-1, depending on how big the plant is. So this is not a single boiler, but if my boiler plant, so I have 2 500,000 BTU boilers, that means I have a plant that's 1 million. So this kicks in, I have to have a 3-to-1 turn down. So if I have a 1 million BTU boiler plant, I either have to have 3 single stage boilers, or I have to have 1 or 2 ones that modulate, right? So I can have one boiler, 1 million BTUs, that modulates as long as it can go down to 33% firing rate, or I could have 3 boilers that go on and off, and that would still get me to 33%. And if you don't know the turn down lingo, 3-to-1 means that I can modulate from 100% down to 33. 4-to-1 means I go down to 25%. 5-to-1 means I go down to 1/5, which is 20%, right? So if I got a medium-sized plant that's whatever, we'll say 6 million BTUs, right? I have to have a 4-to-1 turn down. So I either had to have multiple boilers that get me down to only providing 1/4 of 6 million, right? Or I got to have 1 or 2 that modulate. So this is going to change the game quite a bit. Modulating boilers have already been growing in popularity for energy efficiency reasons, controllability reasons, things like that. So this is going to help that discussion along quite a bit. It doesn't mean you can't use old single-stage cast iron boilers. You could, or an old steel boiler, or say even a new cast iron single-stage boiler. You could still use those things, but now you're going to need more of them, which means that from a cost perspective, is it cheaper for me to put in 4 one-stage boilers to get my 4-to-1 turn down, or is it cheaper to put in 2 modulating boilers, right? So it's going to change the math on a lot of these projects. By the way, unlike the previous discussion we had with boilers where we're talking about hydronics, hydronic hot water, this doesn't say hydronic hot water. This says boiler. So this would include steam systems as well as hydronic hot water systems. So if you're going to do a steam plant with 6 million BTUs, you better have at least 4 boilers at a minimum there, because steam plants don't typically modulate. They're typically on-off, right? Because it's really hard to make steam with less heat. All right, so keep that in mind. One other one too, for both boiler plants and chilled water plants, when we're at reduced capacity, we have to be able to have pump isolation and reduce the flow down, right? So chilled water plants, including more than one chiller, right? Obviously, we're going to call it a plant. You have more than one chiller. You got to be able to reduce the flow automatically. That means not a person doing it. The controller has to do it on its own through the chiller plant when the chiller is shut down, right? So if I got 2 chillers and I shut one of them off, I got to cut off the flow through that particular chiller, right? Because that flow is just a bypass path, which is causing mixing and diluting my water temperature. Same thing on the boiler discussion, right? So I got to have automatic shut-off capabilities of the flow whenever I stage down boilers or chillers. Commercial duct sealing. This has not really changed in terms of the way the language is written. However, there's been plenty of misinterpretations on this, just like there has been on the residential side, so I wanted to just kind of cap it a little bit. In regards to insulation, that's that first section up there. As you can see, if my return and supply ducts are in unconditioned spaces, I got to insulate them to R6. So unconditioned spaces are places that, the easiest way to think of an unconditioned space is if you didn't put a supply diffuser in there, you didn't plan on heating and cooling it, so it's an unconditioned space, right? So if you run your ductwork outside the warehouse and then into the office area of a building, that warehouse is not conditioned space. You got to insulate the ductwork to R6, right? That kind of thing. And then if you run it run it outside, depending on the climate zone, you're going to have, beefier insulation. If you run your ductwork outside, you're already asking for problems, but sometimes you got to do it. So you're going to have R12 in our climate zone 5. In regards to duct sealing, it really depends on the pressure class of ductwork. There's low pressure, medium pressure, and high pressure systems. Low pressure is under 2 inches static design, medium is 2 to 3, and high is 3 and above. All of these systems have to be duct sealed, and if you read the language, it explains what's specifically required and what you can do. You can use mastics and tapes and all these different things to seal the duct. And then most of the time, they point you back to the IMC on specific rules on how to properly insulate it, or sometimes things get pointed back to SMACNA standards and stuff like that. So you have to seal all ductwork, low, medium, and high pressure. The real difference comes in on the high pressure duct systems, which I'm showing here. So on high pressure, which is 3 inches and up, not only do you have to seal it, you got to pressure test it down to a certain leakage. Very similar to the residential thing. The residential thing, you had to seal every single duct, and then if the duct went outside the thermal envelope, you had to pressure test it. Commercially, it's a little bit different. You got to seal all the duct types, but instead of something to do with in the envelope or out of the envelope, we look at the pressure of the system. If it's 3 inches and up, then we got to also test it to prove we're down to a certain leakage. That leakage rate is a 4.0, and this is very similar to what the SMACNA standard has. That's basically your measured leakage rate per 100 CFM of duct surface area, which is a very hard thing to figure out, but you got to be able to use a calculator and a ruler, divided by the static pressure you tested it at to the 0.65 power. I don't know why they had to make the formula that complicated and make us do to the 0.65 power. It's probably to sell more calculators, but that's how you would actually calculate your CL level, and you got to be a 4 or less. So the idea there is we'll stop designing stuff above 3 inches. Above 3 inches, we not only want you to seal the duct, we want you to test it, because honestly, the higher the pressure you operate at, the more CFM you're going to actually leak, because leakage out of a duct is a function of pressure differential. So the room is at a certain pressure, or the space at a certain pressure that the duct's in, and if my pressure inside the duct is 3 inches versus 1 inch, well, my differential is 3 times as big, and I'm going to leak a lot more conditioned air out. So it's not a function of inside or outside the building envelope like residential. It's a function on how high you're operating it, pressure-wise. There are a ton more rules that we're not going to have time to dive in deeply. I wanted to just mention a few of them so you can look them up on your own if there's something that you're involved in. These ones did not really change a ton. They're the same as the old code, so I didn't really focus on them much. There may be a few changes. Like I said, I haven't read every single word. But there are whole sections on pipe insulation, right, for both domestic water and hydronic piping. We still got the fan power limitation rule, which everybody hates because it involves lots of math and figuring things out. You're only allowed a certain horsepower for your air handling systems, and you get credits to earn more horsepower by putting extra stuff in. So if you put an ERV in, then you get a bigger horsepower budget, if you will, than on a system that doesn't have an ERV. But basically, they're trying to get the horsepower down lower because that is a direct function on energy consumption. There are rules for the fan efficiency itself. If you install anything outdoors to heat something, right, you want to put in a heater in front of your dock door. You're a hotel in downtown Chicago and you want to heat the sidewalk area for the doorman and the people coming in and out. As soon as you do outdoor heating, it has to be a radiant type heating system. That would basically mean two things. It could be PEX tubing embedded in the concrete floor or something like that to heat up the ground and radiate the heat to people. Or it could be like an infrared heater, right, whether it's electric or gas, either way, shining down on you with infrared rays. But you cannot heat the air or anything like that. You got to heat with radiant if you're going to heat outside. There's a whole section on rules on limiting hot gas bypass. Those rules look like they're exactly the same as the previous code, but those still exist. And in general, you can only put hot gas bypass on the first stage. Stages 2, 3, and 4 can't have hot gas bypass. And by the way, I didn't mention it, but on those requirements for having 2 stages or 3 or 4 stages of cooling capacity on zoning systems, those requirements specifically prohibit you from counting hot gas bypass or RAL devices or anything like that as a stage, because hot gas bypass is an energy waster. It's great for controlling the situation, but it's not good for saving energy. We'd much rather have more stages to step down. Although they realize sometimes you just can't step down practically low enough. So on the very first stage of cooling, you are allowed to use some hot gas bypass, but there's a whole set of rules on limiting that you need to study before you do that on a job. The economizer section is out of control. It's like 4 pages long, and and it's in different spots, like 3 different spots. There's economizer rules. So I might have to do a separate webinar just on economizers. I might do one on economizers, one on VAV control systems, and one on hydronic systems as kind of like little mini webinars to kind of supplement this one. There's lots of rules on when you got to put a VFD on a motor, depending on the situation, what the motor is being used for. Over certain horsepowers, you got to put VFDs on. There's a whole slew of rules relating to cooling towers, and that may be a separate webinar topic in and of itself eventually. And then every single piece of major equipment type has a table for minimum efficiencies, just like the rooftop one that I showed you. And almost all of those tables have increased targets you got to hit from what you used to have to do last year. So chillers, condensing units, PTACs, all of these pieces of equipment have new tables. So every manufacturer's piece of equipment isn't going to comply because they make equipment for the whole country. And when they ship it into Illinois, that entry-level chiller or entry-level rooftop or whatever probably ain't going to cut it. You're probably going to have to go with a better one. So this is, for example's sake, is the table for chillers. And if you look at air-cooled chillers, we're up to a reasonably high efficiency. If it's a small air-cooled chiller under 150 tons, I got 2 choices to comply, path A or path B. Path A always means that I want a really good full load efficiency and a mediocre part load. Path B means the opposite. I want a mediocre full load, but a really good part load. Personally, I'd rather have the good part load because I spend more time there, but they recognize some plants are not operated that way, right? So they give you both ways to comply. So you have to do either path A or path B for all of these chiller types. And the numbers are much higher than they used to be for both air-cooled and I think they bumped up for water-cooled as well. So that's one to pay attention to here. Let's do quiz question number 6. True or false, commercial boiler plants greater than 1 million BTUs need to have a turn down of at least 3 to 1. True or false? Simple question. Let me look at a couple more of your questions. Bernadette asks, does the manufacturer of the RTU need to comply with C403.31 and associated table C403.31? In other words, is the responsibility of the manufacturer or the specifier specifically on packaged rooftop units? Without going and pulling, maybe I can pull up real quick to see what C403.1 is because I don't have the section numbers memorized. 403.31, let's see. That is not where I want to be. All right. Oh, 403.3. Should have picked an easier question to read. Jeez, where's it at? Oh, okay. So that one is the cooling turn-down ability. This one was specifically applying to if you had systems that modulated airflow to control space temperature, so zoning systems, basically, airside zoning systems. Right? So your question was, whose responsibility is it to comply? That's a great question in general. So in regards to all the building code stuff, the responsibility of compliance falls, as it always does legally, in multiple people's laps. In the end run, the building owner is responsible to comply. But as his advisors, we've got to do a good job making sure we do the right things. So if there's a professional engineer on the job, I would say there's a very high responsibility level for the professional engineer to make sure things comply. Because the owner doesn't understand the codes and they're looking to you and hiring you to come make their stuff comply. If it's a simple change out of a rooftop and there's no engineer per se and the contractor's doing it, then the contractor's responsible to make it comply. In regards to your question about the manufacturer's responsibility to comply, the manufacturer builds equipment for all portions of the country, so they are not going to build every single piece of equipment to meet everything in this code book because this code book only applies to 3 or 4 states right now. So you're not going to be able to have them comply at the manufacturing level. It's got to have to be complied at the state level. Let's close our poll question here. So 95% of you said that is true, which is correct. If my boiler plant is 1 million BTUs or greater, I got to have the ability to turn it down at the rate of 3 to 1, so down to 33% firing rate. I got to get it down to. So most of you guys got that one right as well. Let me hide that. We'll go back to this. All right, a few other points, and then I'm going to read through the rest of the questions. The energy code is the state law. Everyone has to comply with it. I realize that some towns don't have an inspector, or some towns don't enforce it aggressively, or something like that. It doesn't mean you don't have to comply. You have to comply with the code. right? Ignorance is no excuse. If you get taken to court and say, well, the inspector didn't make me do it, that's not going to fly, right? It's written, it's code, everyone knows about it. They may not know the exact verbiage and what it means, but they know there is a code. So you got to make sure you comply. If you're bidding against another contractor or engineer or whatever, and their bid is excessively lower than yours, I would take a look at their bid and see if they're complying with the code. If they're not, I would let my building owner know that, hey, the reason you don't have apples to apples is this guy's not doing the current code. Either make him comply with the code or ask me to bid a non-compliant system and you take responsibility. I wouldn't do that. That's dangerous, but you know what the point is. Let me read through a couple more of the questions here and try to answer some of these. Some of these look like they're pretty good ones. Dan asks, if a unit is 20 tons, how does it achieve 4 stages of cooling? He's asking if economizer, 2 stages of cooling, and 4th. So that's a good point. The economizer is not a stage of cooling as far as the code is concerned. Let me go back to that table for you. You need 4 stages of mechanical cooling, Dan. Right, so that example there is the one he's looking at. I need 4 mechanical cooling stages. And if you read it, I'm specifically not allowed to use anything that creates a false load. So controls shall not be capable of creating a false load in the mechanical cooling system by limiting or disabling economizers such as hot gas bypass. So I can't count the economizer. I can't count hot gas bypass. If you got a raw device, that's still hot gas bypass. I know they say there's a little bit better and all that. Fine. It doesn't count. 4 stages of mechanical cooling. That means I need 4 compressors, or I need 2 compressors that each have 2 stages, or something like that. Right? So hopefully that clears that one up. James says section 403.3 has an exception for economizers for systems less than 54,000 BTUs that have DX coils. Once again, I don't have the sections memorized, so let me find that. 403.3. Oh, it's the same one we were just on, right? Economizers, the exception you're referring to, 54,000 BTUs. That 54,000 BTU is only in climate zones 1A and 1B, James. So you're looking at note 2 there on the bottom left of my screen. Is that what you're looking at? Right, in climate zones other than 1A, other than 1A and 1B, where individual fan coolings have a capacity of less than 54,000 BTUs and meet one of the following: direct expansion, total chill water system less than. What else do we have? Oh my God, there's 9 notes. Holy cow. I think I read this wrong last time. So you have a good point there, James. When I read this, I was thinking that note was just for 1A and 1B, and I skipped over it. But the way it's worded is note 2 is anything other than 1A and 1B. So in that case, 54,000 BTUs and under, which is 4-ton units and down, you would not have to have an economizer. I believe I read that wrong and hence interpreted it wrong. So 4 tons and under, you would not have to have an economizer, as long as you have a DX system, which would be every rooftop unit. So that is a good point, James. You are correct. I read that section wrong. Bernadette asks table 403.2.7. 403.2.7. Well, let's see if we can get back to that. .2.7. That's not that one. All right, ERV. Does it apply to heating and ventilation systems? So you're asking if you need an ERV on a heating only system as opposed to a cooling system. I don't believe there's any exception in there for that. Okay, so note number 3 is your possible exception, Bernadette. If you have no cooling whatsoever and you don't heat the space above 60 degrees, you don't have to do the ERV. But if you decide to heat the space to 70 degrees, then you do have to do the ERV. Steve Watson says, does economizer count as a stage of cooling? Okay, so that's the same as Dan's question. No, the economizer does not count as a mechanical stage of cooling. Bill asks, does the turn down ratio apply to steam boiler systems? Yes, he probably typed that question before I addressed steam. Yes, all boiler systems have to comply. At no point in that section of the code does it say anything about hydronic or water. It says boiler systems. So yes, steam boilers have to apply, And because steam boilers typically don't modulate, they're typically on-off devices, you would need 3, 4, or 5 steam boilers depending on the size. Lucas says, for VRF systems, we interpret the exception 403.3. 403.3, let's go to that. Where's 403.3? Getting closer. 403.3 is airside economizers. Exception 2.1. 403.3, exception 2.1. Trying to figure out what your question is here. The cooling coils in the VRF indoor unit are refrigerant DX. Do you disagree? I'm not really sure on the question, Lucas. I'm trying to find your exception 2.1 you're referring to. Oh, maybe I'm too far down. 403.3. Okay, here we go. 403.3, exception 2.1. So that was a discussion we were just having before with the 54,000 BTUs. So with a fan cooling unit. So a fan cooling unit is not the outdoor tonnage of the VRF system. It is the indoor air handler piece. So if the indoor air handler is a 5-ton unit, it's going to have an economizer, right? If it is a 3-ton unit or a 4-ton unit, it's not going to have an economizer on that VRF discussion. So it's based on the tonnage or based on the BTU capacity of the fan cooling unit, not of the outdoor condensing unit. So hopefully that clears that up. Glenn says, is TEC selling equipment that is non-compliant with, and then he stopped typing. Oh, there's another question. Non-compliant with something. He left, didn't finish sentence, but then later says, therefore, TEC selling only compliant equipment as of today. So TEC does stock non-compliant equipment. As you probably know, we do business in lots of different states. So we have equipment that would be compliant with IECC 2015 and equipment that's not compliant. So if you really wanted to, you could probably buy a non-compliant unit and you could probably install it wherever you want if you didn't get caught. However, I would advise you in Illinois to go ahead and just follow the code and not be that guy, right? Some people may get away with some things like a programmable stat. If you get caught, you go put one on. A rooftop unit, you buy one that's not efficient enough and someone catches that, now you got a crane coming back out. So especially on big stuff, I don't think I would necessarily go that route. Ron asks, any advice on writing simple commissioning procedures? No advice, Ron. I don't think commissioning is simple. That's why everybody does that commissioning is either an old engineer or a middle-aged controls guy, ex-controls guy, because it's got to be somebody that can handle weird, complex stuff. So no, it can't be simple, Ron. You're perfect for the job. Mike asks, it looks like the fan power box motors now need to be included in the fan horsepower limitation rule for the system. This is a change from the previous code. Please confirm. Mike, I've not dug in deeply to the fan horsepower rules, so I'll have to get back with you on that. If you remember, send me a note and we'll try to talk about it later on today or on Monday or something. I've not dug into that. Robert asks, what section is VAV fan power boxes in? It's in lots of places. That's why I said I might have to be a separate webinar for VAV systems because it falls in a lot of the control sections. As Mike just mentioned in one of the other comments, it looks like it might fall under the horsepower rule for the air handlers. So lots has to be addressed with the fan power boxes. There's no specific section per se. Patrick asked, will this webinar be presented again or available for download with audio? No, not presented again. Yes, I am recording it, and we'll post that recording. So if you got a coworker that wants it, we can send them the link. John's question about fan horsepower rules for the terminal unit. Oh, he's answering Mike's question. He's saying that was the same as 2012. So Mike, John is responding that the fan horsepower rules of including the terminal unit was the same in the 2012 as it is in the 2015. But I've not really read that. John says that I should have been done talking 9 minutes ago. That is true. Mike asks, is hot gas bypass an energy waster? It is definitely an energy waster. What hot gas bypass does is it falsely loads your evaporator to keep your cooling system online so it doesn't stage down, so you can continue to cool and dehumidify on low load scenarios. So sometimes it's needed because you want to cool and dehumidify in low load scenarios, but it does not save you any energy. In fact, it uses more energy than if you did nothing. But sometimes you got to do it because the load is so tiny. Jay says, did you say that economizers are only required on 4 tons and above? Originally, I said all systems because I did not read exception 2 clearly. But now, Jay, I'm changing my tune because one of you guys pointed out and I still got on the screen right now, in climate zones other than 1A and 1B, so pretty much everywhere except Miami, they're giving you an exception if your indoor air handler is less than 54,000 BTUs, which is like 4.5 tons. Then you don't have to follow this section here for including an economizer. So the economizer are not required in these scenarios. So that's one of those scenarios. 54,000 BTUs, for sake of argument, is, oh, where did my calculator go? Is 4.5 tons exactly. Okay, so 4.5 tons. If it's less than 4.5 tons, you don't have an economizer. So 3 and 4 ton units don't require an economizer. 5 tons and up do require an economizer. All right, I think I got all the questions, so we can actually close out here. And if anybody has any future questions, you can send them to me. If it's something I know, I will answer it. If something I don't know, I'll try to look it up. And if it's neither one of those things, then I'm sorry. And the webinar recording should be posted in about an hour. It takes a while to compile the video and then upload it, but we'll get it posted up there pretty soon for you. Thank you guys for coming. If you have suggestions for future webinars, send them to me and I'll try to accommodate them if possible. Thank you.